Hello, and welcome to this brief demonstration of how I use GeoGebra in the classroom. So to do this demonstration, let's just start with a calculus question. This is a related rates question, so it's a question about how two rates relate to each other. And this is the first question that I ask the students when we start our related rates section. So you have a 10-foot ladder resting against a wall. The bottom of the ladder is initially 1 foot away from the wall. The ladder begins to fall, and the bottom of the ladder moves away from the wall at a constant speed of half a foot per second. Okay, then I ask the students these two questions. I write these on the board, and I write the first question without writing the second question. So at first, they only see question 1 here. So after 2 seconds, how fast is the top of the ladder moving? And then once we answer that, we ask the same question, but for 3 seconds. So before I move on, I should mention that I'm well aware that this question is not particularly interesting. But I do have good reasons for starting with this question. This is a brief demonstration, so I won't give you those reasons. But in any case, if your reaction to this question is, wow, that's really boring, you're correct about that. But I have good reasons for starting with this before we move on to more interesting questions. Okay. So to answer question 1, I don't use GeoGebra. We just do the calculus, we do the algebra, and just for the sake of argument, let's say that we get an answer of -3 feet per second. And if you're worried about the negative sign, that is correct. The top of the ladder is falling. All right, so here's the top of the ladder. Over time it will fall, and that negative sign is just keeping track of that negative direction. And this is something that I discuss with the students. Okay, so we've done question 1 without using GeoGebra. And now when I write down question 2, if a student doesn't make this point, then I will. So I'll say, okay, the bottom of the ladder is moving at a constant rate of speed. Therefore, it stands to reason that the top of the ladder is also moving at a constant rate of speed. Therefore, we don't have to do any work. We can just say that the answer is the same as number 1. If the top is moving at a constant rate of speed. Right? We can say this, can't we, class? And they agree with me because they agree with anything I say if I say it with confidence. Okay, so, but that's a question, right? Can we just write -3 and move on? So here's where GeoGebra comes in. So this window over here is GeoGebra. So what I do is I show them a little animation of this situation. So here's the wall. Here's the ladder, the purple, and it's 1 foot away from the wall. So I'm going to turn a movie on of the ladder falling. And what I tell the students at first is, keep your eye on the bottom of the ladder. Notice it's moving at a constant rate of speed, right? Now, look at the top of the ladder. Is it moving at a constant rate of speed? Well, the answer is no, right? Even though the bottom is moving at a constant rate of speed, the top is accelerating. Right? Its rate of speed increases. It starts off falling slowly, and then it speeds up. Okay, so let me turn this off. So this kind of point is very difficult to make on the whiteboard, but using this little animation, students can see that we can't just write -3 here. We'll have to do the calculus and algebra again. So these questions aren't just exactly the same. So that's an example of how GeoGebra can be used in the classroom.